Bismillahirrahmanirrahim. Assalamu alaikum students. This is a subject of chemistry for class 9th. This is lecture number 7 of unit 6 solutions. The topic is preparation and dilution of solutions, which is given in your book on page number 165. This numerical is related to the preparation of solutions. So here we have an example 6.6, which is prepare 0.3 molar sodium carbonate 250 centimeter cube of solution. So here we have sodium carbonate, which is a solute, and the required molarity or the given molarity is 0.3 molar, and the total amount of solution is 250 centimeter cube of solution. So from this example, here we have given data. Calculate the mass of solute needed. We don't have a solute here. The mass of solute is required, so the mass of solute here, we do not know that what will be the mass of that solute, so we need to calculate that mass of solute. So the molarity is 0.3 mole per decimeter cube. Here the molarity of sodium carbonate is 0.3 molar, so this value 0.3 molar per decimeter cube come from the above example. So volume of solution is 250 centimeter cube, so this centimeter cube is converted to decimeter cube. So 250 is divided by 1000 because 1 decimeter cube is equal to 1000 centimeter cube or 1000 ml. So 250 centimeter cube is divided by 100 unit, so this is converted, centimeter cube is converted to decimeter cube, so it becomes 0.25 decimeter cube. So here the formula of molarity is number of moles of solute divided by decimeter cube or liter of solution. So here we don't know that what is the number of moles of solute. Here we have another formula, which is number of mole of solute, which is mass in gram of solute divided by molar mass of solute. So here mass in gram of solute is unknown, and we have to calculate the molar mass of solute. The solute is here sodium carbonate, so we are going to calculate the molar mass of solute, which can be calculated as molar mass of sodium carbonate. So here we have 2 sodium, so 2 is multiplied by sodium plus carbon. Here we have 1 carbon, so 1 multiply by carbon, and then plus 3 multiply O. This O is oxygen, so 3 multiply oxygen. The values of sodium, which is 23, carbon 12, and oxygen 16 come from periodic table, which is the atomic masses of these elements. So 2 multiply 23 become 46, and then 1 multiply 12, and then 3 multiply 16 become 48. So when all of these are added, so the value become 106 gram per mole. So this 106 gram per mole is the molar mass of sodium carbonate. So here in this formula we required mass in gram of solute. So mass in gram of solute is equal to molarity multiply molar mass. Where this molar mass come from? So this molar mass is in division, so it become in the multiplication with the molarity, and then decimeter cube or liter of solution is also in division, so it goes to that side and become a multiplication. So here the formula become mass in gram of solute is equal to molarity multiply molar mass and multiply decimeter cube of solution. So here we have to calculate the mass in gram of sodium carbonate. So the molarity and the above numerical is 0.3 mole per decimeter cube, and then it is multiplied to the molar mass, which is 106 gram per mole, and then the volume of solution, which is in decimeter cube of solution, so it is 0.25 decimeter cube. So when all of these values are multiplied with each other, it become 7.95 grams. So this is the required amount of solute, which is to be dissolved in the little amount of water and then diluted to 0.25 decimeter cube or 250 centimeter cube to make the whole solution. This is another kind of situation. How to dilute a stock solution? So first of all, what is a stock solution? Stock solution is basically a concentrated solution which is already present in the lab. So you have to dilute Dilution means that you have to add some amount of solvent to that solution to become dilute solution. Basically, dilution is done by a formula which is dilution formula, which is given as m1 v1 is equal to m2 v2. So this m1 v1 is for solution number 1 and m2 v2 is for solution number 2. Here we have an example 6.7 which tell us that what of volume water must be added to 70 centimeter cube of 2.4 molar potassium permanganate to dilute it to 0.35 mole per decimeter cube, which is the unit of molarity. So you have to write a solution. From the above numerical we have a given data which is m1 is equal to 2.4 mole per decimeter cube. So here we have a concentrated solution of potassium permanganate. We have to dilute it to 0.35 mole, which is dilute solution, and 2.4 mole per decimeter cube is a concentrated solution. So you have to dilute this 2.4 molar solution to 0.35 molar solution. So here we have m1 for stock solution or concentrated solution 2.4 mole per decimeter cube, and volume number 1 for this solution is 70 centimeter cube. So here we have the diluted solution which is 0.35 mole per decimeter cube. So what amount should be added to this 70 centimeter cube of solution with molarity 2.4 mole per decimeter cube to become 0.35 mole per decimeter cube? So here we have a formula, dilution formula, which is m1 v1 is equal to m2 v2. So putting all the above value in this dilution formula, so m1 is 2.4 multiply 70, which is the volume, and is equal to 0.35, which is the molarity of the dilute solution, and then v2. Here v2 is unknown, so this is multiplied, which become 168, and then divided by 0.35. So v2 is equal to 480 centimeter cube. This v2 is the total volume of dilute solution. So here we have already 70 ml in the first solution, so we have to subtract this 70 from the 480 centimeter cube. So v2 is the required amount, which is 410 centimeter cube, which must be added to the first solution to become the dilute solution. This is assignment number 1 for you. You should solve this assignment in your home and then send us Viva images or PDF file for checking. So the question number 1 and this assignment number 1 is a 0.125 mole sample of sodium hydroxide is dissolved in sufficient water to produce 1725 ml of solution. What is the molarity of solution? So you have to find the molarity of solution. So by using the previous formula you can solve this very easily and clearly. So molarity is equal to number of moles of solute divided by decimeter cube of solution. So you can solve this problem with that formula. Another question is how many moles of lithium chloride are in 3.5 liter of a 0.16 molar lithium chloride solution. This is also solved by the molarity formula, so you have to do it yourself. Question number 3 is how many grams of magnesium chloride are in 1.75 liter of a 0.64 molar magnesium chloride solution, and then here we have molar mass, which is 95.2 gram per mole. So this is also done by molarity formula. Question number 4 is what is the molarity of solution formed by mixing 1.5 liter of 6.0 molar nitric acid HNO3 with water to get a final volume of 6.5 liter. So this one is a dilution formula, so you have to solve it by a dilution formula, which is m1 v1 is equal to m2 v2. The last one is what volume of water must be added to 50 centimeter cube of 2.7 molar sodium nitrate to dilute it to 0.52 molar. So this is also solved by dilution formula. Students, if you have any kind of problem in this lecture, so you can ask. Thank you.